travels in a straight line and then comes to rest at Q, which is 969 meters away from the time. The total time is 66 seconds. For the first 10 seconds, it has uniform acceleration, then travels at constant speed, and is finally brought to rest by uniform deceleration A2, acting for 6 seconds. So, what I'm going to do is I'm going to grab myself this box here, okay? Actually, I can't even get to the box. I'm going to do it down here. Okay, and what I'm going to do is just going to color away this. Why am I getting rid of the bottom part here after A1 and A2? It's a second question. It's a separate question, isn't it? So I don't need it for a minute. Just need the board space, that's all. So I'm going to start here. What type of method do you think it is, and why? Why does it have to be velocity time? One object, different accelerations, clearly different phases in its journey. Okay, so you accelerate upwards, you stop, you go at constant velocity. I have no idea which one's better, A1 or A2. Well, I do actually. A2, it decelerates in 6 seconds compared to 10. So definitely the deceleration has to be stronger than the acceleration. You're allowed to do what you want, by the way. Anyways, here we go. Okay. Now, what we're going to do is we're going to put 10 here, yeah? And we're going to put 6 here. And what can I say about this middle region then? Anybody tell me what I can say about the middle region? 50. Do I know how what the velocity is, the final velocity? I don't, do I? Okay, no hassle. We'll just call it V, will we? Now, they foolishly gave me the total distance. So what does that mean? The area under the graph is 696. So get the area of the triangle, the area of the rectangle, and the area of the other triangle, and it should equal 696. So first triangle, a half 10 times V. That's your triangle. Your rectangle is 50 multiplied by V, and your last triangle is a half 6 times V. And then I think what I'm going to get is 5V plus 50V plus 3V, which I'll agree equals 58V. And 58V must equal 696. Divide 696 by 58, and what do we get? 12. Okay. So equals 12. Now, do you remember what I said about tan of the angle? What did I say about tan of the angle, guys? Huh? Opposite over adjacent, 12 over 10. So the acceleration is 12 over, which is 1.2. The deceleration is 12 over, which is 2. Forgot my units, be careful about that. Deceleration, its magnitude is 2, but it's obviously a -2 because it's slowing down and not speeding up. Thank you. Now, we're going to go to part 2 now. Dun, dun, dun. Okay. If the journey is from rest to rest, having travelled with basically no what? No speed limit. Okay, so that's going to be awkward. So, we're just going to remember quickly that my acceleration is 1.2. My decel is magnitude 2, but obviously -2. And how am I going to change my diagram here? Straight up, straight down, yeah. So I'll draw that going up, and I'll draw this one. Ah, come on, you. I'll get rid of you and keep you. And don't like the lack of accuracy. There we go. Something along the lines of that. Is that okay? And I'm going to draw a vertical line. Now, here we go. We all good? Now, what we said earlier is the following. We went that... So rest to rest. What's the area of this full triangle? 696, right? Is it still 66 seconds? Why not? That was when you went constant speed. So that 66 seconds is out the window. So we're very much running off only three items of information: the acceleration, the deceleration, and what else? Oh, sorry. No, 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 no. Show that. Not allowed to use it, but you have to prove it. Yes, sir. Well done. Spoilers. I was about to tell you that, but he got there before me, all right? So if you remember correctly, do you remember back in the day we said if you had an acceleration of 5 and a deceleration of 10, because your acceleration, because your deceleration is twice as powerful, your acceleration time would be 2t compared to t on the deceleration. Do you remember we did that ratio trick? Okay, it's going to be something similar here. So what we could do is we could do it a bit like this. We could say it's a ratio of 1.2 is to 2. So you could say that that's 2t and that's 1.2t, because the deceleration obviously is the time taken deceleration is shorter than the time taken accelerating. Yes, sir. You could if you wanted. Being lazy, just decide to switch them around and chuck a t on them. But absolutely, you can make them whole numbers if you want. Now, what we're going to do next is, we know this is v, don't we? And what can we say about tan of the angle? Tan x is v over 2t, which is 1.2, implies that v is 2.4 t. You all okay with that? Next thing I'm going to do is I'm going to get the area of the full triangle. Now, what's the base of this full triangle? 3.2t. From base to base, we're talking 3.2t. So how do we get the area of that triangle? A half. The base is 3.2t. Its height. It is. I'll put down v for the time being, but you were dead right. And he got a software upgrade, so he's running faster today. Now, so he's right. We got to sub out the v with what? 2.4t. And now we're down to one variable, aren't we? And what's 3.2 multiplied with 2.4 and then half your answer? So we could do that really quickly. 3.2 multiplied with 2.4, half your answer. What? 3.84? T, yeah? And then divide that 3.84 into 696. So you're going to do 696 divided by 3.84. What? Really? Okay, we've gone wrong somewhere. Something went really wrong. Oh, t squared. Ah, the t squared got us. So what I want you to now to do is to square root this. I knew that number was way too big. It was a proof question, wasn't it? We had to prove that total time is 6 root 29. So it was way too big. So what do we get now?
29.
29.
That's what I got.
So what are you saying this is in short form? 5 root 29 all over 2. Wait a minute. I was meant to get 8 root 29. Ah. I know. Just trying to bait it out of people. So our t value wasn't the total time, because we said our total time was 3.2 t. Multiply said answer by 3.2. Now what do we get? There you go.